Hello, welcome. Green. Okay, and I'm going to go live on my other platform, Facebook. Go live. Hola, it's Latrell, and we are live for the KOG math homework help. Got a little bit of something I was doing last time. Forgot to clear the screen, but thank you for joining me tonight. Um, I see that a few people shared my event that I made about this that I actually don't know. And maybe we can get a few different people joined on today asking your questions. And that's going to be really exciting. So I've been tutoring all week and I have been helping some people who are taking algebra. And let me just write the name up here. KOG, sorry, live algebra homework help. All right, cool. So I have gotten a good amount of students in the past like week and a half, and I'm practically booked up. So that's really awesome. I enjoy tutoring, I enjoy helping people, and I'm excited to hone my skills and really dig into what students need in their math classes. So please bear with me. I'm sharing my live video in my group and on my page and on my event. If you have a question, go ahead and ask. I will get started answering it. I love doing this. Last week it was very fun. We had a bunch of people hopping on, posting their questions in the comment section. Um, and we really dug into answering the questions and a little bit more. I was able to give out a free download. Actually, it was free because I found it online, so it was free to me. So I gave it out to other people, which was very helpful. So I don't know if I can share this on that event that I made, but either way. Oh, we got one person in. Do you have a question? All right, let me hop on this. Thank you for, hey Carla. Thank you, girl. Hey Lauren G, what's up? Thanks for coming and hopping on. So, some of the things that I experienced and helped people with this week, just so you know, my name is Latrell Jackson. I'm a math tutor. I went to Rider University to be a math teacher, and um, right now I tutor privately and in an after-school program in Trenton High School. And I really enjoy what I do. Like, it just brings me a lot of joy to help people to understand um, what they're struggling with and to show them the little itty bitty things that are tripping them up and maybe making them get the wrong answer or a more complicated way of doing something, helping them to see the full process so that they can start making shortcuts for themselves, for yourselves. So I just wrapped up my Ask Me sale. I had a sale going on for my Ask Me service, which is a question answering service. And you can submit your math question or concept. Maybe you don't understand linear equations, or maybe you don't understand how to find the slope of a line, which is what we're going to be going over today. And what I'll do is make a video tutorial and send that to you along with a screenshot of my notes, and oh, so that you can really get the understanding of what you need to do in order to really understand that type of problem. So that finished up yesterday. It was the 31st, was the last day of the sale. It's still, it's still available. It's just not on sale anymore. I think I'm going to put it back on sale on Black Friday. I know a lot of you guys are going to be wrapping up your courses. If you're in math class, you're going to be um, just getting ready for finals and things like that. And that's a good time to ask your question, because it may be something old that you didn't understand from earlier in the semester that's going to be on the final. Think about that, because right after Thanksgiving break, you're going to be on break, you're going to be with your family and stuff, you're not really going to be studying, and it's going to be hard to study. So it's going to be hard to focus on the things that are impending on for when you get back to school, which are tests, assignments, projects, and things like that. So go ahead and shoot through your questions so that I can help you get a better understanding. One-on-one tutoring, got that, but it's kind of booked up. But I always say I am looking for tutors, math tutors. So if you know someone, or if you are someone who wouldn't mind being coached on how to teach in a way that students of all ages can understand and feel comfortable with you, then send me your information, DM me, because I'm ready to expand my business to another level. Learning center in the works. So let's start talking about linear equations. I had a session this morning, and the student was dealing with perpendicular and parallel lines. Do those sound familiar to you? And I was trying to help her. Hey, everybody that joined in. Jerry, hello. Sean, hello. Um, so linear equations, if you look at the word linear, you'll see the word line. And linear algebra is basically about lines, just about a whole bunch of lines. How do you find them? How do you locate them? How do you name them? How do you create them? And things like that. So with a line, you can have the line in different going, let's say, in geometry, a line is um, basically a string of points that goes in opposite directions forever and ever. Looks like this, right? There are different ways that you can draw a line. You can draw a line flat like that. You can draw a line like this. You can draw a line going up. And you can draw a horizontal line. And any variation of the diagonal lines as well. Also, please share out to your friends and family if you know they need any help, just so we can get the word out. and get more people getting the help that they need in their math class before it's over. So think of, let's look at this first line. Hey, Ryan, let's look at this first line. So let's say we got this guy named, let's pick Ryan. I'm gonna pick on Ryan. Let's say Ryan is walking on this line, right? He's this guy walking on the line. And if he's walking on the line, it's comparable to walking on the sidewalk, right? Usually if you're walking through your neighborhood, you're not really going uphill too much or downhill too much unless you live in like California or some really hilly place. Um, Usually you're walking on a flat surface. So the slope or the slant of this line, you would be able to say that it doesn't have a slant. It doesn't incline or it doesn't decline. So that means that the slope of this line is equal to 0. Slope means M is slope. Let me backtrack. It's like people go to the slopes when they're going on the mountains to ski and things like that. Melly Mel, what's up? Welcome. So Ryan right here, Ryan is not increasing or decreasing. He's walking and he's having a good relaxing walk. All right, let's look at this line right here. Ryan is having a hard time walking down this line or walking along this line because it's going downhill and it's actually very steep. It's negatively steep because it's going down. So we can say that this slope maybe is a hill or is a mountain. Maybe he's going on a hike or something like that. Got some good boots on so he doesn't, mess his good shoes up or his ankle and whatnot. So we can say that this slope is a negative slope. Okay. Let's move on. He might fall down this line, so you got to be a little careful. Let's look at this line right here. Whew. Ryan is getting his workout on because he is going uphill. He might even be at the gym on that machine, that treadmill where he inclined. He's walking on an incline now, and that's adding to his workout because it's a little more work. Sometimes it's a lot more work depending on how steep you incline the machine. So he could also be on a hike. He could also be on a hill. He could be walking through his neighborhood too. I mean, where is it hilly? We're from Trenton. Most of us are from Trenton, so um, it's hilly in West Trenton, I think, in Ewing too. I think a little bit, but this line represents a positive slope because it's going uphill, up positive. So this slope is a positive slope. And my cousin Mary's supposed to be watching this video too. She requested that I talk about linear equations. Thanks for the thumbs up. Okay, let's look at this last line. This is impossible. Ryan, he would have to climb. Let me get him a little closer. He would have to climb this line if he was going to do it. Look at his little arms. He's trying to make it up there. This slope or this incline is just impossible. Like it's undefined. You can't walk on it. It's impossible to walk on this line. If you think of that roller coaster King Ka at Six Flags, that is almost really a straight up and down roller coaster. You'll never find me near that roller coaster. I'm just not a roller coaster person. I definitely ain't getting on that one. So the slope of this vertical line is actually called undefined because it literally you can't define you can't walk on it. Can't do the thing that you want to do. Like Ryan wants to walk, he can't walk on this line. So it's actually undefined. And it can be proved mathematically as well. I'm not just saying it's undefined or it's impossible because you can't walk on it. It's like mathematically proven. So usually in math we write undefined this way. So we went over the different types of lines. We got flat line, which is zero slope, a decreasing or declining line, hey Miss Corrine, which is a negative slope, an increasing or an incline, which is a positive slope, and then a vertical line straight up and down, which is a undefined slope or undefined slant. So the next thing we should look at is points on a line. So let me erase this. This is actually, I like how this looks. I'm going to save it. One second. If anybody has a question, go ahead and, send it through. I just want to save this. Okay. So now we're going to look at points on the line and how to graph points. Real quick. Little bit of a different color. Purple. All right. So if we have a coordinate plane, this is a coordinate plane. Sorry for my lines not being straight. Ooh, that's a little better. A coordinate plane. My student today drew a little diagram to help her see which areas were positive and negative, and I should have took a picture of it because it was so like understandable. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, -6, -1, -2, -3, 1, 2, 3, 4, 5. Okay, so thanks for person who's sticking with me. Oh, I think it's Miss Corrine. Hi, Miss Corrine. So on this coordinate plane, we can plot points. So first thing we need to understand is that this line, this vertical line, is the y-axis, and this horizontal line is the x-axis. So let's say we plotted this point right here. We plotted this point, okay? Cool. Thank you for sharing, Miss Groons. We plotted this point, and yay, there it is. How do we locate this point? First of all, we always start from the origin. The origin is the beginning. That's why it's called the origin. Always start from the origin, which is 0 for everything. It's 0 for y, and it's 0 for x. As you see, if we go to the left or to the right, to the left of the origin is positive numbers. To the right of the origin is positive numbers. To the left is negative numbers. Then if we look below the origin, it's negative numbers, and above the origin is positive numbers. Okay. Where's our line? Our dot. Our purple dot is in this first quadrant. So this is quadrant 1. quadrant 2, quadrant 3, quadrant 4. Our dot is in quadrant 1, and both the numbers on the x-axis and numbers on the y-axis that is associated with this dot are positive. So the way we first look at the how far to the right it is from the origin, how far to the right it is from the origin, and then we look at how far up it is from the origin. So first to the right, and as you see, x, this is called the coordinate point. X is always first, and then y is second. X then y, x then y. So how far is it to the right of the origin? Well, it's 1, 2, 3 from the origin. So we can label the first part of our coordinate point as 3. That's the x value. And then the question is, how far up is it from the origin? It is 1, 2 up. And so as you can see, we got this dotted line that shows us, that shows the direction that we go to find the point. It's 2 up, and so there you go, 3, 2. 3 to the right and 2 up. Let's find another point. Let's go into the third quadrant. Here we go. So want to locate this point. Remember, we're using x, y as our basis. X is the x is the x value, y is the y value, and this is called a coordinate point. We want to locate. Remember, we look at our x first. X tells us how far left or right we go from the y tells us how far up or down we go from the origin. So looking at our yellow dot, did we go left or did we go right? We went left from the origin, starting from the origin. Left from the origin, how far left? 1, 2, 3, 4. And that 4 is negative. So, excuse me. So the x value for our coordinate point is -4. And then the question will be, are we going up or down from the origin? And here's the origin. It's yellow dot now. And we actually go down from the origin. How far down? We went -3. We went 3 down. So that answer would be -3 for the y value. There you go. Okay. That actually looks really cool. I love the dots and the different colors used, and they complement each other, and I'm just admiring this beauty right here. All right. So, we know how to plot our points. If you need a more of an explanation of that, you can comment in description. I mean, in the comment section. Appreciate it. Appreciate everybody who has joined me as well. And Joseph, thank you for sharing. What I'm going to do now is um plot a line. So let's look at the 2 points that we have. We got this yellow point, which is -4 comma -3. And then we got this, I want to make it blue now, this blue point, which is 3, 2. Cool. What we could do is actually connect those dots. Let's connect those dots. So I have a ruler here. I'm trying to figure out how to use it. Isn't this awesome? All right, how do you do it? How do you do it? I don't know if y'all can see this. All right, I'm not using a ruler because I don't know how to work it. Okay, we're just gonna freehand the line, and I'm using purple again. Excuse me. Connecting these two dots with a line. Does it go to the origin? I think it actually does if I use the ruler. Awesome. Cool. I didn't mean to do that, but it happened. You know why it happened? Because we have -3 over here, and no, that's not why, actually. So these dots are connected by a line, and thanks to the person who jumped in. Nice seeing you. And what else was I gonna say? These two dots are connected by a line. It's not drawn straight, but I did the best I could. What we can do is now determine what kind of line it is. So remember we had the different lines. We had up and well, we had a vertical line, a positive line, a negative line, and a horizontal line. So which one is these? Looks positive to me. So positive, or the classification of a line, is always how we look at it from left to right. So remember, over here is left and over here is right. So if we took our hand and smeared it over the coordinate plane, that line, as our hand um, covered the coordinate plane from left to right, it would be increasing, it would be going up. So that's how we can tell that the line is positive and has a positive slope. Okay, cool. We got 2 points on the line. So let's do something. Let's find out what the actual slope is of this line, and that can be done given the information that we already have. So we have these 2 points. We got 3, 2, -3, and -4, -3. The equation for a slope, because before we said we were able to classify whether it was positive or negative. Now we know that the answer is going to be negative. Now we know that the answer is going to be positive because the line is increasing. Let's see exactly, let's get more specific with how positive this slope of this line is going to be. So the equation for slope is y2 minus y1 over x2 minus x1. Okay, we didn't see this before. This is our first time seeing this. I'm talking about in this video. So what I'm going to do is help to locate and identify what y2, y1, x2, x1 is. I'm going to go back to our original points and just label the coordinate point values. So the first point, this is point 1. We can say that the x is the x1 and the y is the y1. And so this one is, the yellow one is point 2. We can say that the x is x2 and the y is y2. Okay, that makes a little bit more sense of what we're about to do. We're about to plug in. So what's x2? What number is x2? X2 is actually -3. What number is y? Why do I keep saying the wrong thing? What number is y2? Y2 is -3. What number is y1? Y1 is +2. So all we did was plug in. Instead of writing y2, we wrote -3. Instead of writing y1, we wrote 2. I'm going to take out the parentheses. Now we're looking at the x's. Which number is x2? X2 is -4. And which number is x1? X1 is 3. Remember, we're subtracting. Okay. So now all we do is simplify. Look at the numerator, which is the top of the fraction, and we do that subtraction. -3 minus 2. This is another thing I had to review with a student that I tutored this week, which is um, the manipulation and operations on integers. An integer is basically a whole number and its opposite, which is the negative of the whole number. So a whole number could be 5. The opposite of that whole number is -5. Both of these are considered integers, including 0. So it can be a little tricky sometimes when you are subtracting and adding negative numbers. And I understand that. That's why I always whip out the number line. So let's say we have -3 on this number line and we're subtracting 2. So subtraction always goes to the left, as you can see on our coordinate plane. Subtraction is to the left of the origin, which is 0. Subtraction, negatives. And positives are always to the right of the origin. Hey, anybody who just joined in, thank you for coming. So we're subtracting. We're starting at -3 and we're subtracting 2. Starting at -3 and we're subtracting 2. So that's 1, 2. What number do you think that is? -4, -5. Hope we can see that line green. Let me use a different green. We got 1, 2. The answer for -3 minus 2 is -5. So that's the numerator. Then we're doing -4 minus 3. So let's redo this. -4 minus 3. -4 minus 3. Starting at -4, we're doing subtraction. So that means we're going to the left. -3. 1, 2, 3. So that was -5, -6, -7. What does that look like? We got -7 in the denominator. What does that look like? If we did 4 plus 3 and if they were positive, we would get +7, right? And for the numerator, instead of doing -3 minus 2, if we did 3 plus 2, we would get 5, right? So I like to call this subtracting in the negative world, or um, adding in the negative world. Both of the numbers are negative. So we got -3, and we can say -3 plus -2. -3 plus -2 is -5. So this it's like adding in a negative world. Same for -4 plus -3. And this is actually, me writing that plus sign is also allowed, because it's going to turn into negative anyway if you simplify the signs. And that -4 plus -3 is -7. So there you go. We got our slope, m equals -5 over -7. And once we simplify it, because negative divided by a negative is positive, hey, Miss Ronette, and that is going to give us a positive 5/7. So there you go. The slope of the line that we just drew, this one over here, the slope of it is 5/7. That's awesome, because I just made these points up and we actually found the slope. So what does this slope mean? Its slope, you ever heard of rise over run? If you're in high school or college, then I'm sure you've heard of rise over run. What this slope is telling us is that on the line, in order to get from one point to the next, we rise 5 points, or and we run 7 units. So running would be going to the right. Rising obviously would mean going to the up, going up. But we can have the opposite where it's drop over run the opposite direction. What would that be? Run the other way. And you're going to the left. Rise over run to the right or drop over run to the left. That's what would take you in the opposite direction. So let's test this. So we're at 4 negative 4 negative 3. Okay. So let's rise 5 starting here at negative 4 negative 3. Let's rise 5. So it's 1 2 3 4 5 and run 7. 1 2 3 4 6 7. Yes, we made it to the other point. That's awesome. That's really fulfilling in my life. I love stuff like this. And you should too, because it proves that the slope that we found mathematically is also being proved graphically. And it's very helpful. Hey, Alexa, I see you. Thank you for jumping in. So we found the slope two ways. Like I said, mathematically, algebraically, and by plugging in the points that we had on the graph and connect the lines to. And then we found the slope graphically by going from one point and going up a certain amount of points or units and going to the right a certain amount of units. And it happened to be the same as the slope, the same amount of units as the slope. All right, cool. So what else can we do? Sometimes you are given the question about perpendicular and parallel lines. Let's talk about parallel lines first. Let me erase some of this. Oh, should I? This is like a work of art, in my opinion, but I can recreate it. Good. How are you? I am going to start talking about parallel lines and perpendicular lines and what they mean. So, parallel lines are lines that never touch. They look like this. They are twins, actually. They are twin brothers or twin sisters. And hey, Cassandra. And they never touch. They go in the same direction forever and never touch. These are parallel lines. Um, Also, these lines have the same slope. Oops. So the equation, if you ever find the slope for one of the lines and you see another line that is not touching it, going in the same direction of it, then the slope of that line is the same as the other one. Um, there's another type of pairs of lines called perpendicular. And perpendicular lines actually cross at a 90-degree angle. Coordinate plane. Awesome. So it can either look like straight up and down or um, like a cross, like an X. Really got to be like careful with this. Like, okay, so this is 90 degrees right here. That's 90 degrees right here. Also, It can be like another color. It can be brown. I want to make it like slightly slanted. There you go. And here's the other one. Ooh, I'm trying hard, and I think I did okay. Another perpendicular set of perpendicular lines. Okay, so parallel lines have the same slope. So their M would be the same. M1 is the same as M2. However, for perpendicular lines, it is something different going on. The slopes are the negative reciprocal. Slopes are negative reciprocal. So this is how it looks. M1 equals negative 1 over M2. That's how that looks. Let's look at an example. Okay, so let's say this line has a slope of 5. The slope is 5. What is the reciprocal of 5? The reciprocal of any number is basically 1 over that number, or flipped. That number flipped over the division bar, the fraction bar. So this 5 doesn't look like a fraction, does it? Well, it also can be written as 5 over 1, right? Because 5 over 1, when divided out, is the same as 5. It equals 5. So if we found the reciprocal, um, I hope this is the correct way to spell it. I've been getting it wrong all day when writing emails and stuff. Reciprocal of 5 over 1, that means we flip it and it's actually 1 over 5. That's the reciprocal. So if we want the perpendicular slope of this slope 5, then that means we have to find the reciprocal and make it negative. So it's going to be negative 1 over 5. That is slope of M2. See, M1 equals 1 over M2. Okay. So let's say we don't have, or we do have a fraction. We do have a fraction, and the fraction is maybe 2/3. M1 is 2/3. So what's the reciprocal? M2 would be negative 3/2. That's the reciprocal slope. Okay, cool. Does anybody have any questions? If you have any questions on the replay, if you're watching on the replay and you have questions, you can go ahead and put it in the description, the comments. This is just kind of a review of linear equations, and there's a lot to it. And I know that a lot of you are at that point in your algebra class where you're studying linear equations. And I know another topic I saw this week was division by polynomials, polynomial division, using long division and synthetic division. That's another one. Thanks for person who just hopped on. I see you. So let's see. We got perpendicular, we got parallel. All right, let's do a really hard question using the information that we just gave. So this is a challenging one. Let's say we're finding a line that goes through negative 4, negative 3, but is perpendicular to the line that we have. Actually, we can't do that yet because we didn't talk about equations of a line. So that's what I'm going to talk about now. Equations of a line. We found the slope, which is half the battle, and the rest of it is pretty simple and straightforward. So equations of a line. Usually you'll see y equals mx plus b is called the slope intercept form. Slope intercept form, it basically takes the slope, put it where it needs to go, and the intercept, put it where it needs to go, and you're able to identify where it goes on the graph and just draw your line like easily. So we said that the slope for this line was m equals 5/7. That's the slope for this line. So what we can do is plug that right in where m is. Leave everything else the same. M equals 5/7. I kind of want to write that in a different color. Pink. 5/7 times x. Okay. Hello, person who just jumped on. Flomo. What's up, Flomo? Flomo is a tutor too. You got a question, Flomo? Um, we have to talk? Oh, okay. Well, let's do it after this. So y equals mx plus b. We got our m. We identified our m as slope. The other thing that is stagnant in this equation is b, which is the y-intercept. Y-intercept. Let's think of that word. Intercept. Intercept means that you're basically crossing something, and y-intercept gives it away. You're crossing the y-axis. So the question is, where exactly does this line cross the y-axis? It looks like it's at 0, the origin. It looks like it crosses right at the origin. But we could be wrong. It could be crossing a little bit to the left, to the right. It could be a decimal, because I just drew this freehand. But we want to make sure we're proving what we're talking about. We want to make sure we prove it. That's the thing about mathematics and why it's so tedious, because we can't just assume. You got to prove it using the process. So our y-intercept, we don't know yet, but we do know 2 points that are on this line. I see 2 points. We got 3, 2, and -3. -4 and -3. So what we can do is take one of these points. I'm going to use 3, 2. Plug it into our equation. Remember, our coordinate points, x, y. We have numbers to replace and represent our x, y, with 3 as our x value and y as our 2 as our y value. We're able to plug in for x and y because we have so many x's and y's on this line. Like literally, we have an infinite amount of x's and y's of x, y coordinate points, because this line goes on forever and ever to infinity. So 3, 2 is just one of those trillions of points. For -4, -3 is another one of those points. So they identify, just like we have cells in our body and we have DNA in our blood. We get a sample. We can give a sample of that. Even in our hair and our saliva, when we give a sample or somebody is able to get some of that, they can tell who we are. They can tell who we are by our DNA on our skin, saliva, whatever, blood. That's the same with this line. Any one of these infinite amount of points can give us information on where this line is located. It can identify this line. That was amazing. I just came up with that off the top of my head. I'm going to put it in my course. So we got 1 point. This is going to tell us where on the y-axis this line intercepts it. So let's plug in. y is 2 5/7, x is 3 plus b. Okay, so Flomo sent me a DM. So let's simplify. We want to isolate b. So we got 2 on this side. Let's leave that alone. Let's do this multiplication right here. So we got a fraction times a whole number. I was just doing this with one of my students today. We can make this fraction into, this whole number into a fraction by writing it over 1, just like we did with when we were talking about reciprocals. Don't forget that plus b. And then when we are multiplying fractions, we multiply straight across the top and straight across the bottom. So we got 2 equals 5 times 3, that's 15. And then 7 times 1 is 7, plus b. This is a little bit more difficult than anticipated, but it's a good thing because it is packed with basic skills that we need to review. And I say we need to review because I've tutored a wide range of students, and I just know that these are some of the weak um, the weak skills that we need to strengthen, which is dealing with fractions, multiplying, dividing, subtracting, reducing, all of that. And like I said before, integers. So we want to isolate b, but 15/7 is being added to it. I want to get that 15/7 away from here. Bring it to the other side, in other words. So we're going to subtract because 15/7 is positive. In order to cancel out that positive, we do the opposite, which is add a negative to it or subtract it. 15/7 minus 15/7 on this side. 15/7 minus 15/7 is 0. And b equals 2 minus 15/7. What? How are you going to plot that? We got to simplify it. So once again, we're going to change this whole number 2 to a fraction by writing it over 1. And we have 2 fractions that we're subtracting, but the denominators are not the same. If you need help with fractions, I have a section in my free mini course on my the link that's in my description, the description of this video. There's a course in there about fractions and what to do with all of the operations. So the way we subtract these 2 fractions is we had to make the 2 over 1 into a fraction that has a denominator of 7 as well, so that both denominators can have the same number. I'm gonna bring this somewhere else. So we got 2 over 1 minus 15 over 7. And to make the 2 over 1 have a denominator of 7, we multiply the top and the bottom by 7. Why? Because out, we're making sure that um, the the fraction is proportional and the ratio stays the same. The ratio was 2 to 1. When we multiply 7 to the top, we get 14. Multiply 7 to the bottom, we get 7. 14 divided by 7, that is still 2, which is what we originally started with. 14 over 7 minus 15 over 7. 14 minus 15 is actually negative 1 over 7. Cool. We got the y-intercept. The y-intercept, remember this is b. Always was b, never changed from b. Just forgot to write it. So what we can do is go back to our original equation. I'm going to rewrite it. Y equals, we got our 5/7. I'm going to fill that in a second. Now we can add our y-intercept. I just want to use different colors. So 5/7 is our slope, and then our y-intercept is -1/7. Cool. So remember when I said, "Ooh, it looks like the line goes through 0." Well, it doesn't, because this 1/7 tells us that the y-intercept is not 0, but the y-intercept is 1/7. Let's see that as a decimal. Y'all, I'm having fun. This is my jam. 1 divided by 7. It's a really small number. It's a number that's really close to 0. So we can rewrite this as a decimal, which usually is not written that way. We can say y equals 5/7 x minus 0.14. And that makes sense because it's really close to 0. Mad close. It's like less than a quarter, less than 15 cents. If you had 15 cents and that's all you had, you'd be broke. You'd be close to broke. So that is the equation of the line that we pulled out of the air. We grabbed some points, put it on the graph, and we produced a line. This was fun. Let me know if you understood, if you did not, if you learned something, and I will be so delighted to get your questions in the Ask Me question answering service, and I can explain in more in detail, because just to let you know, this is not the depth that you need to um, understand linear equations. This is very surface, but I gave you an overview, and I feel like what I talked about today flowed and helped you to see generally what linear equations is about. If you need a more in-depth understanding, you can head over to Ask Me and submit your question, and we can really go deep into linear equations. Thank you again for joining. That's going to be it for tonight. I have different services that are free that you can benefit from, like my free mini course called The Top 7 Concepts You Must Master to Pass Algebra. Is that Shireen? Hey, Shireen. I have 7 concepts: integers, fractions, prime factorization, greatest common factor, least common multiple, radicals, and exponents. That's a lot right there. And guess what? It's free. And I have videos, have a lesson, I have quizzes, I have downloadable study guides for you to use for when you are doing your homework and things like that. So go ahead, if you need that, sign up for it. The link is in my description, and you can go ahead and get your basics, your math basics strengthened. Um, like I said, I have the Ask Me service, and I'm preparing to launch a membership, an academy for those who are taking math class and need like constant support. And I think this is going to be just amazing for you guys and anybody who you know could benefit from it. Sneak peek, it's actually launching or pre-launching in December. So right after the semester ends, a couple days after that is when I'm going to pre-launch, and then I'm going to launch in mid-January of 2019. So you want to get on the wait list for that. Link is in the description for it of this video, and you will be able to benefit from some really, really good, deep um, support, understanding, community, and all the other things that I have planned for you. It's coming soon. So I'm going to say goodnight. Thank you so much for joining. Thank you so much for all those who shared, popped in, um, shared, tagged a friend, or let a friend know about it. And I'm going to get ready for bed for tomorrow. Good night, everyone. Bye. Mm.